For our third example of using the enhanced unit circle to figure out trig ratios for multiples of 15 degrees, we're going to be evaluating secant of 195 degrees. Now recall that the reciprocal identity for secant is 1 over x, or 1 over cosine rather. So since secant is 1 over cosine, if we know cosine at 195, we can figure out secant at 195. So let's go ahead and follow these steps. Step 1 is to locate the angle on a unit circle, and I usually put a check mark, so I'm going to go ahead and do that. We want to figure out where is 195 on our enhanced unit circle. Well, we know it's going to be past 180, and in fact it's going to be 15 degrees past that. So here we are at 195. Now is x positive or negative there? That's important to know, right? Because secant is 1 over x. So therefore if we look, we can see that x is negative there at 195. So that's part of the reason why we do step 1, is to try to visualize what's going on. Step 2, determine which axis it's closest to. Well, like we just saw, 195 is closest to the x-axis. It's closest to 180. Instead of hopping back to that slide, I'll just show you. Okay, so 195, which is about right here, we can see that that's clearly closest to the x-axis. And I need to probably draw that angle coming out. Okay. Step 3, determine the sign of the trig value. Okay, so since we know that only tangent is positive in the third, then we can also understand, apart from the fact that x is negative, that secant must be negative there as well. The only other trig function that's positive is cotangent, but we know that from the reciprocal identities. So it's basically just knowing the reciprocal identities, and all students take calculus. Step 4 is to determine the corresponding angle in the first quadrant. Okay, so I will go back to it so you can see here. What would be the corresponding angle in the first quadrant of 195? Well, again, it's closest to the x-axis. Which of these two angles, 15 or 75, is closest to the x-axis? The answer is 15. So this is our corresponding angle and point. And again, secant is 1 over x, so we're going to hone in on the first part of that coordinate, which is square root of 6 plus square root of 2 over 4. We're going to find the reciprocal of that to figure out what secant would be at 15, and then just basically take that and make it negative to figure out what secant of 195 is. Alternatively, like I said before, you could just memorize this enhanced unit circle and see that the x value at 195 is negative quantity square root of 6 plus square root of 2 over 4. But it's hard to remember that. It's actually, for me, I think it's easier to remember these steps. So, step 4, the corresponding angle would be 15. The corresponding angle would be 15 degrees since it's close to the x-axis. Step 5 is to determine the trig value. So again, to figure out secant of 195, we need to figure out secant of 15, and we know that secant is 1 over x, and we know the x value at 15 is square root of 6 plus square root of 2 over 4. So we're going to do 1 over that x value. We're going to have to flip that fraction since it's 1 over that. Then we're going to have to multiply by the conjugate of the bottom. The bottom is square root of 6 plus square root of 2. The conjugate of that is square root of 6 minus square root of 2. We're also going to multiply the top by that. So it's 4 times the quantity square root of 6 minus square root of 2. Okay, we know that when we multiply the conjugate, the two middle terms cancel. So on the bottom, we're just going to have 6 minus 2, which obviously becomes 4. Now here's what's crazy. There's already a 4 on top, right? There's already a 4 up here. So if we end up with 4 on the bottom, we can just cancel those out, and voila. We get secant of 15 is square root of 6 minus square root of 2. Let's see how that stacks up to cosine. Well, actually, we use cosine, right? Cosine was square root of 6 plus square root of 2 over 4? Really? Wow. So the x value at 15 degrees is more complex than the secant value. In other words, the secant value at 15 ends up being simpler. It's just square root of 6 minus square root of 2. There's no 4 on the bottom, so pretty interesting. Now all that to say, we can use secant of 15 to figure out secant of 195 now. We just said that secant must be negative in the third quadrant since it's not tangent or cotangent, and only those two are positive in the third, and because secant depends on x. So since secant is negative in the third quadrant, we can take the secant value at 15 and just make it negative to figure out secant of 195. So we're going to take this value and make it negative. So if you notice that the sign of the square root of 2 is going to change to positive, and the sign of the square root of 6 is going to change to negative. So just multiply that by negative and then simplify that. Now, for this particular example, we can simplify because we can distribute that negative into both of those. So after step 6 of multiplying that corresponding sign from step 3, meaning we knew it was going to be negative in the third quadrant since it's 195, we can move on to step 7, which is simplify. So we're going to distribute that negative into both. The square root of 6 becomes negative, and the square root of 2 becomes positive because it's double negative, and then we can flip them. Final answer, secant of 195 is equal to square root of 2 minus the square root of 6. Again, secant of 195 is square root of 2 minus square root of 6. And again, we're talking at this angle, 195. Square root of 2 minus square root of 6 is secant. You can see it kind of looks like the y value there, but again, there's no 4 on the bottom, and that's just interesting to me, and that's what happens sometimes when you multiply by the conjugate. That's it for this example of secant of 195. If you have any other questions about this, let me know.